Okay, and can you all see my screen? Yes?
Yes, sir.
Okay. So last week we were doing polymorphism, function and operator overloading to be precise. We now know the basics of operator overloading and function overloading. But we are not quite done with operator overloading, so we'll come back to it later on, but we know the basics. Um, so maybe this weekend, some extra classes. But anyway, the weekdays for this week belong to inheritance. Now, see, the defining feature of object-oriented programming is we can say that it's just classes and objects, right? Objects, hence object-oriented programming. Everything else stems from that. And perhaps just after objects, after the organization through objects, the most powerful, or like, yeah, the second most powerful feature is inheritance. Now, what is inheritance? See, the basic need behind object-oriented programming as opposed to other modes of programming like functional or procedural programming is that nowadays the size of codes is like out of hand of a small programming group. Several millions of lines of codes are required to run practical applications. So like several groups of programmers will create such a code and communicate between one another. And it's not possible for a single person or even a small group of person to know each and every line of the code. And yeah, so just let me digress. So how do people communicate like while working on such things? There's something called the UML which we might touch during the later course of our classes. So unified modeling language, just a kind of representation of a project, of a larger project or larger program, which shows the organization of program according to classes or objects, or according to how the flow of control works, etc., etc. Okay. So this will come to play for a brief moment in today's lecture. Anyway, so the thing is that as you know, programs become several millions of lines long, and the programming responsibilities are spread out over a large team. Each part of the program is tested separately and consume multiple and lots of working hours of lots of people. So now suppose a section of the program has been like perfected, tested, etc. And now the client wants some change. So maybe not fault of the client. His company has different needs now, or there, I mean, some development in the language itself has happened. That can also happen. The thing is that on one hand you have tested code which is working fine, and now you want some extra features in it. So as in object-oriented programming, we can say that our code is already organized on the basis of classes and objects. So how do we deal with the extra features? In procedural programming, the functions would be changed, etc., etc. But then that would kind of effectively waste much of the, what do you call it, working hours spent in testing the functions, because maybe you delete something important or you modify something in some bad way or add some bad things that makes the function fail. So inheritance offers a solution that from an already existing class, we can inherit everything that it has. Furthermore, this new class that is derived from this old class we can modify. So we want some new features. So you need to modify only some things in the class. So as we inherit members of the original class, we can keep some, we can discard some, we can modify some. This opportunity is provided by inheritance. So yeah, the class that is created from the old class, the new class that is created from the old class is called the derived class, and the old class is called the existing or base class. The derived class inherits all the capabilities of the base class, but yeah, it can add and refine the members of the old class. The thing is that the base class is not affected by what the derived class does. It functions exactly as it was before this derived class was even created. So let's see some examples. So yeah, so as we were talking about this UML class diagram, Unified Modeling Language class diagram. So, one of the types of class diagrams is to represent the various classes and show how they are related. Okay. So usually while doing this, see base class, we may have some base class, and then we have some derived class. So usually we think that the arrow goes like this, but somehow some bad convention, the arrow is shown like this. Okay, so so it is like this class is derived from that, goes like this. Okay. Yeah. Okay. So the main benefit of inheritance is code reusability. Okay. All right. So let's see an example. So we have we had this simple class counter, and so connected. Okay, so one more thing is that why are we saying protected besides having public and private? Is that, see, something is private means it cannot be directly accessed by anything outside of the class, and public means it can be accessed. So since we are doing inheritance, some inherited class, the members that the inherited class can access, I mean obviously public members it will be able to access, and private members it cannot access, but sometimes you would want a derived class to access some members which are not available for access to anything else other than a derived class. So protected means that category of members which only derived classes can access, not anyone else. So it is something between public and private. this is the no argument constructor. This is the single argument constructor, and this one we'll see. It just returns count. And finally, okay, I think we should, we'll just make this display count, but later on. Okay. This is plus overloaded. Turn counter plus count. Okay, we are yet to write the main function, so that will be there. Fine. So yeah, this is our base class. Now so this is just a counter class which increments a counter. So this increments a counter, right? Now we'll want one like a counter that counts down. Okay, so decreasing the value is required. I'll come back to what public means later on. Result f plus this count. All right. So let's see what this does. So we have just added another, like the countdown operator, right? And so we are, so this is the object of the derived class, and we are accessing get count through the derived class. Now, this looks bad. Okay, so the I mean, you can see that we are basically accessing the members of the base class through this derived class. And yeah, so initially the constructor initializes C1 to 0, so that's what C1 is first. Then we use the incremental operator from the base class, which like size we increase, so 3. And after that, this new addition to this class is the countdown operator, which we do twice. So just demonstrate something. What is the name of this? A counter. Counter C2. So to this level, everything will be identical, because we are accessing the members of counter directly through an object of counter. That is fine. But if we do this, then we get an error. So this is not doable. Base class cannot access the members of the derived class. Okay, so the syntax, I'm not describing what public means right now. The syntax of deriving a class is basically, you say it's a class as usual, and you name the class, then there's a colon, and then you write public. You could write something else also, which we'll come to later. Then you write the name of the base class. So that's how you do this. Okay. So the accessibility we know is basically what it's doing is, let's go to the definition.
Sir,
is yes.
so the minus operator works for the objects of count down class, like
Yes.
count dn class.
Yes.
So why are we returning counter object?
Where?
Sir, in the definition of operator yes, sir. Counter count.
Here?
Yes, sir.
Oh, it is. Yeah, that's the question. So because see, this is So this is the when you talk of this counter here. Because what can we say? So this function is defined on the type that this function so whatever this function returns, the data type is counter. Okay, because if you write count down here, it does not make any sense, because the member variable itself is inherited from counter. Yeah, because so if I write count down here, not here. Let me make a different thing. Okay. So if we write count down here, then the compiler will be confused as to where this variable count is inside the class countdown, because see here I have never mentioned any variable. Okay. So let's see what happens. So yeah, it's looking for the count variable inside this class itself. Okay. So it doesn't. I mean, this class, not yet. It doesn't contain its any like independent variable of its own. Yes. So what was the other thing that I wanted to show you? Okay. So I'm not, if I don't make this protected. I mean, by default everything is public, right? Okay. Sorry, by default it's private, or is it public? Yes. Let me see. Let's check. So this is declared private here. So yeah, in a class by default, like I mean, if you don't declare what type of member it is, it's a private member, and it cannot. The class cannot. I mean, our derived class cannot access it. But if we had made this public, then we'll be fine. Okay, so let's where was I? Okay, accessing base class members. All right. So what else can we do? We have added a function. Yes. We have a constructor here, right? Okay. So how about we can we write a constructor depending on this? Counter. Let's see if this makes any sense to the compiler. Okay. So just I will run the previous class, previous code just once. It was giving 3.1. Okay, so this was the value of C1 after increment, and this was after decrement. 3 and 1. Okay. 0, 3 and 1. If we do this again. 1.5. Okay, we are not being able to do this. Why? It's not so. It's not accepting structure. It seems. Let's see. So constructor is not. We're not allowed to change the constructor. It seems. Can we? So I guess for constructors we should use this, or no. Same error it is giving. So apparently we cannot do anything to the constructors as well. Okay, but can we change the other member functions?
Sir, you have declared count as protected. That's why I think you can't change. Maybe we can declare it as public and then declare the constructor.
Okay, let's see. Maybe yeah, that makes sense. Let's do this then. No, it's not working. But okay, so we'll come to this later, whether constructors can be changed or not. But certainly can we, okay, forget about constructors. Can we do something to the, I mean, what if we have, what is the increment operator? Yes. Return counter. Plus count. Let's encourage in a bit of blasphemy. You're not supposed to do this, but yeah, you're not supposed to subtract when the function itself means addition. But just let's Okay, it was unsigned. So yeah, it was unsigned. So let me just. This is 0, right? 10. Okay. Yeah. Now you can see that. Yes, you can see that if I'm accessing. So if I'm working with an object of the derived class, and if in that derived class I redefine a function that is written in the base class, then our derived class object will use the new meaning. Okay, it will use the function that I mean with respect to the derived class, the function of the base class has been overwritten. Okay, so whenever you work with work with an object of the derived class, it will consider the overwritten function. Okay, like the new version of the function. So it is subtracting. Sure. Because for the derived class, I have said that even plus plus means a subtraction operator. Okay. All right. Yes. Right. Let's. Okay. This was about your ordinary functions, but let's wrestle a bit with the constructors. I'll just get rid of this here. Well, so we have this no argument constructor and this one argument constructor. Okay, and fine. What did I write for the constructor? Just let me copy. Okay. Expected unqualified ID before this one counter than no argument constructor. And does this work somehow? Okay, so just before I explain, let me do another thing. So this is our zero argument constructor. Okay, and what about the one argument constructor? So just let's see. The value assignment, how it should work. Is this all right? It is all right. And just let me make this 1 and see if everything is Okay. Just before we go into this, let me also experiment with the one argument constructor. That is, there is, yeah. So this should also be accepted. So what exactly is happening here? So counter basically it returns value, and so the object of, I mean, here the object that, I mean, what the compiler does, what the compiler seems to be doing, it is creating an object of type, data type countdown, and then it is calling this countdown constructor to initialize it. Okay, and so this countdown constructor is apparently, it has something to do with the counter constructor, which is why we get this. Okay, and no, so this countdown so this countdown constructor is probably adding some statements to the counter constructor, and so just to demonstrate this dependability, let me let me remove this. Okay, just let me remove this one. Okay, so I mean, to demonstrate it better, I will remove this one here. Which is all right. So now nothing, I mean, the one argument constructor, so the one argument constructor of the derived class is gone. So there's no dependency on this one argument constructor of the base class, right? So just see. Okay, it's doing something. No, so yeah, this is being called here. So yeah, this is not a good way to demonstrate the thing. I'll have to remove more statements from the program. Just let me comment out these. Okay, let me comment out these. Fine, and let me pretty much remove everything. Fine, okay. So now we have okay. We have removed the one argument constructor from the derived class. So just let's check once more. So the one argument constructor of the derived class is there. There's no problem. we remove the one argument constructor of the base class, and there's a problem. But if we remove the one argument constructor of the derived class, no, then also there's some problem. So the dependency is it like this? Just one second. Yes. Okay. So yeah, it turns out that both of these constructors were invoking the this guy here, the one argument constructor here. Okay, and they were passing the values 1 and c to this original constructor, and that is why we were getting error. So I mean, the constructors of the derived class are not independent. They depend on the constructor of the derived class. So just let me see one thing. This is 1, and this was giving an error. Okay. And if we keep the one argument constructor and remove the 0 argument, just to reinforce our conclusion. Yeah. So you can see that the 0 argument constructor does not play a role here. It is the one argument constructor that is invoked by the constructors of the derived class. Okay. All right. So overriding functions is done. One more. So let's see one more example. And we'll have our well-known distance class. Okay, why am I writing this? I think we can. This was the one, right? Yes. So I'll make it inherit 4. This will be protected. This is fine. This is fine. This is fine. This is fine. Okay. We don't need these two. integer. So sign distance. Just I'll define sign this here. What's the keyword? Enum, right? So this neg type, which is either positive or which is either pos or neg, and public sign is equal to pos, and this sign and feet float in pos neg st equal to pos. This is distance in, and yeah. And we need to print a plus or minus, right? So our get dist function show dist. Let's show dist. So one was show dist, the other was get dist. No? Okay, both of them. So we need to do this for both. You have to enter a sign plus or minus in ch, which is a character. Sign is equal to, this depends on the character, right? So you're getting a feel of what you did in the lab, though a very brief feel, but yeah. And we have this show list, which is does not mess with the values, but only prints. Else okay. So we have overwritten the get dist and show dist functions. This thing will be assign just one. All right. Assign this two is this. This sign. Okay. So this is, we can make this sign, which is the argument constructor, and we need a three, maybe make this up, and make this will be a 3 argument constructor, and just one show list. So yeah, we don't need this. Okay, let's see how this works. What is the problem? 63. That is fine. This is all right, and oops, 55 FT is not a plus, that is on enumeration. This is just, it was thinking some other thing. $10 feet, 10 inch. Okay, yeah. So you can see that, yeah, we have overwritten and added features to the already existing get dist and show dist functions in the base class. The derived class is more elaborate. Okay, and yeah, so it's time anyway. We'll continue with inheritance tomorrow. Okay. And in today's lab, we will continue doing mathematical operations. So this is our last lab for mathematical operations. We'll slowly generalize to algebra from next week. Okay, so see you at 2 o'clock.